Okay, so this will be our last optimization example for the videos for Math 1560 Calc 1 at U of L for fall 2017, and of course we'll have several more that we're going to do in class on Thursday. So for our last optimization example, we've got another kind of financial example here. And again, I mean, these are contrived examples, right? They're not necessarily realistic, but they give us simple examples where we can work out the numbers that give us an idea of how we might do these things in more realistic problems. So in this case, we've got an apartment building, 100 apartments in it. I suppose all apartments are the same because they all rent for a cost of $800 a month. And the manager has conducted some sort of market survey and found out that, well, for every $10 that she increases the rent, the one unit is going to become unoccupied, right? So as the rent goes up, the vacancy will also go up as some people can't afford the apartments. I suppose this is the idea. So every time she adds $10 to the rent, one unit is going to become unoccupied. And now her job is to figure out, okay, what rent should she charge if she wants to maximize the revenue, the amount of money that the apartment building is bringing in. Okay. So let's think about how we do that. Well, let's let X be the number of apartments rented. Excuse me. Let's let R be the rent. Okay. And so our revenue, let's call that big R, is just going to be the number of apartments rented times the rent per apartment. Okay. But now, what we really need here is we need to write this in terms of the increase in rent. Okay. So we are going to let N be the number of $10 increases. Okay, and so then we know that the rent is going to be the initial rent of 800 plus 10 times N, right? And the number of apartments rented, X, is going to be the initial number, 100, minus, well, for every $10 increase, we lose one unit, right? So 100 minus N. Now we've written everything in terms of this single variable, the number of increases. So R, as a function of N, is going to be 100 minus N times 800 plus 10N. There we go. Now, one kind of, I guess, issue that we could take with this problem is that N is a positive integer here, right? Is N is an integer bigger than or equal to 0, we can't really do calculus with an integer variable, but we can kind of do this approximately. Assume that N could be a continuous variable, and so maybe you could consider half an increase, so they only add $5 to the rent, or a tenth of an increase, they add $1. You could get down into the pennies. So we could consider fractional values for N, and from there it's not too big of a leap to consider that N could be a real number, and that'll allow us to do calculus, right? So we've got R as a function of N, and actually we have a domain for N, and this time we do get a closed interval, right? N has to be bigger than or equal to 0. It's the number of increases we're going to make. And n can't be negative, right? Because we've already rented all of the units. So lowering the rent is not going to do us any good, right? It's fully occupied at $800 a month. The only way to go is to increase the rent. So n has to be bigger than or equal to 0. And, oops, why did that sound just go off? Okay, so n has to be bigger than or equal to 0. And it can't be any bigger than 100, because if n hits 100, well, then there are no units rented, right? And we don't want that either. Okay, so n has to be somewhere between 0 and 100. Good. Now, where do we go from there? Well, we optimize. Okay, so we need the maximum of r of n on this interval from 0 to 100. So let's do the calculations on the next page. So r of n is 100 minus n times 800 plus 10n. We could multiply that out if we want. Use FOIL, multiply it out. That might make the derivative a little bit easier, but we could also just do product rule, right? So the derivative of the first term minus 1, 800 plus 10n, plus the first term times the derivative of the second, which is just 10. So we get minus 800 minus 10n plus 1000 minus 10n. Okay, so we get 200 minus 20n. So if we factor out a 20, that's 10 minus n. Okay, so that means that r prime equals 0 when n is equal to 10. And that's our only critical number, right? And so in this case, because we have a closed interval, we should check r of 0. Well, r of 0 is going to be 100 times 800, which is 80,000. R of 100, that was our other endpoint, right? Remember, n was between 0 and 100. R of 100 is, well, 0, because there are 0 units rented. R of 10 is going to be 90 times 900, which is going to be 81,000. Okay, so by adding $100 to the rent, she loses 10 units. There are 10 units that are going to become unoccupied, but she gains $1,000 a month in revenue because the rent has gone up by 100. Okay, and if we wanted to verify that that's a max, we could do that as well, right? We could. If we just draw this, the easiest way to verify that's a max is going to be to draw our sign diagram here. 0 at one end, 100 at the other, 10 in the middle, and we can see that our signs go like this, so we are going from decreasing to increasing at that critical number. So this is our maximum. Okay, so she should up the rent by $100 a month if she wants to maximize her revenue. Okay, that's it for this example.